Welcome to part 6 of my derivative rules videos. In this video, we're going to learn how to knock out derivatives with the product rule. Don't forget to like and subscribe so you can continue to get these amazing videos. All right, so what is the product rule for derivatives? Let's just dive right into the rule. If f of x and g of x are both differentiable functions, then f of x times g of x is also a differentiable function, and here it is. The derivative of function f of x times g of x. Don't forget this notation, d over d of x. This is the derivative of this function with respect to x. Just means it has x's in it. So here it is. Here is the derivative rule for the product. Okay. Okay. So you take f of x, the original function of f. Don't do anything to it. Just leave it alone. And you multiply it by the derivative of g. So the first part is the original f of x function multiplied by the derivative of g. Then in the back, you add g of x, again, the original function for g, multiplied by the derivative of f of x. That's it. So a couple of things to be careful of here. So many kids make the mistake of thinking that the product rule is just like the sum and difference rule, and they think that derivative of f times g is the derivative of f times the derivative of g. No, absolutely not. Much more complicated. It's the first function, f of x, times the derivative of the second function, g, plus the second function times the derivative of the first. Again, I'm going through that again because I really want to make sure you understand it. Now, a couple important key things here. There is a plus sign in between. Technically, the order of addition does not matter, so you could do this in the other order and it would still be correct. The only way it could be incorrect is if you multiply two derivatives together. If you take the derivative of g, multiplied by the derivative of f, you're going to be wrong because neither of the two terms, this term or this term, have a derivative times a derivative. It's one function left alone, multiplied by the derivative of the other function, and then add, repeating that process, but just switching them, g of x times the derivative of fx. Okay, hopefully that makes sense. But I'm going to show you one other way to view this. Sometimes you'll see this in a lot of textbooks where we use two functions, u and v. So instead of using g of x and f of x, we just try to make it a little bit more simple and just use a u and a v. So the derivative of u times v is u times the derivative of v, dv over dx. That's just our notation for the derivative of v. Plus v, left alone, times the derivative of u. Again, du over d of x, that's just the derivative of u. So again, it's the same exact rule, just slightly different notation. Instead of calling it f of x and g of x for my two functions, we're just using two letters, u and v, to represent these expressions. All right, that's the rule. Go back through it. Listen to me explain it again if you need to, but I'm going to dive right into some examples because I think once you start using it, it's actually not too bad. All right, so here we go. I have a function y that is 3x cubed multiplied by 4x to the fifth plus 2. So the multiplication is occurring right here. So here is my first function, and here is my second function, or my u and my v, if you want to use that second way of looking at it. All right, so here we go. The derivative of y prime, is going to be the first function u left alone, 3x cubed, multiplied by the derivative of the second function, in this case, the derivative of what I'm calling v. Now, to do that, I'm going to need the power rule, the constant rule, and the sum rule. So the power rule is going to tell me that the 5 falls down in front, 5 times the constant multiplier 4, 5 times 4 is 20. My new power is going to be x to the fourth. The derivative of a constant 2 is 0, so I don't even need to write that down, right? Just who cares, right? 0 is 0. So I have the first function u right here times the derivative of the second function v. Plus, now I'm going to repeat that process, but I'm going to switch it around. I'm going to start with v, left alone, 4x to the fifth plus 2 times the derivative of the first function, or the derivative of u, which is going to be 3 falls down in front. 3 times 3 is 9, x to the second power. There you go. I'm actually done. Now, let me emphasize again, the second part was v times the derivative of u. All right, now, this is actually, for some students, the hardest part, is cleaning it up. Actually doing some algebra, doing some reducing, some simplification to just make this look a little bit nicer. So all I'm going to do is I'm actually going to do the multiplication here. So I have a monomial times a monomial. So that's going to be 3 times 20 is 60. X to the third, x to the fourth is going to be x to the seventh. plus, back here I have to do some distribution because this right here is a binomial. It's got two parts separated by a plus sign. So I am going to have to distribute the 9x squared to both of those. So let's see here, 9 times 4, I get a 36x to the 7th plus 18x squared. Hopefully you want to take time to process that. And then continuing on, I recognize that I've got a couple like terms here. I got the 60x to the 7th and the 36x to the 7th, so that can combine to make 96x to the 7th plus 18x squared. Everything in red is simply algebra. It has nothing to do with derivatives. It's all just multiplication of expressions, combining like terms. And for some students, that's actually the hardest part. In blue is just me using the product rule. One more point I want to make when I use the product rule. All four parts always go in parentheses. I can't emphasize that enough. Some kids will forget parentheses, and then when they go to do the algebra, they forget to distribute and all that fun stuff. So please don't forget to use parentheses. All right, let's do another example. All right, I have y, which is x to the 4th plus 4 times x to the 5th plus 2. So I got my u times my v. So the product rule tells me, because I'm multiplying two functions together, take u, x to the 4th plus 4, multiplied by the derivative of v, which is 5x to the 4th. The derivative of 2 is 0, don't need to write it down. Plus, now I'm going to start off with v, x to the 5th plus 2, times the derivative of u, 4x to the 3rd. Once again, the derivative of this 4 right here is 0, so I don't even have to write it. I'm done. That's the product rule. Completely finished. Now I just got to do all my fun multiplication to clean this up. All right, a little bit of distribution here. That's going to be 5x to the 8th plus 20x to the 4th. Back here, a little bit of distribution. 4x to the 8th plus 8x cubed. Combining my couple like terms here, I have 9x to the 8th plus a 20x to the 4th, and then an 8x cubed for my derivative. There it is. Nice and simple. All right, another example here. So once again, I have two functions, negative 4x to the 5th plus 2x cubed plus 1, all multiplied by 2x to the 4th plus 5. Again, the multiplication is going on right there. So there's my u, there's my v. All right, to find the derivative, I'm going to start off with u, negative 4x to the 5th, plus 2x cubed plus 1, times the derivative of v, 8x cubed. Plus, now I'm going to switch it around. I'm going to start off with v, 2x to the 4th plus 5, times the derivative of u, 5 drops down. That's going to be a negative 20x cubed, plus 6x squared, and the derivative of that 1 is a 0, so I don't need to write it. Okay, done with the product rule. Everything I'm about to do now is just good old-fashioned algebra, and this is where so many students make mistakes, so please take your time. Got to do some distribution here, negative 32x to the 8th, 16x to the 6th, 8x cubed. Okay, back here I have a binomial times a binomial, so I got to do a ton of distribution. Let's see, here we got negative 40x to the 7th, 12x to the 6th. I'm going slow because I'm checking my own math in my head, which is what you should be doing too. Negative 100x cubed and 30x squared. All right, combining any and all like terms. Let's see, I got a negative 32x to the 8th. The 16 and the 12 could combine, but first I have the negative 40x to the 7th. Now let me combine that 16, that 12 makes it 28x to the 6th. I have an 8x cubed and a negative 100x cubed. That's going to be a negative 92x cubed. And then finally a 30x squared. Oh, I'm warning you, for a lot of students, that algebra after the product rule, toughest part. Take your time. Product rule is actually quite easy. All right, now I actually want to go back to the first problem that I did. Another way to do this problem is actually to completely avoid the product rule. I don't want to ignore the fact that you could do this. If I actually distribute this, I would get, again, I'm not finding the derivative yet. I'm just doing some basic distribution to rewrite my function. 12x to the 8th plus 6x x cubed. Now, I actually don't even need the product rule. I could go right to find the derivative with the addition rule. So I'm just going to drop down the 8, 12 times 8, grab a calculator if you need to. Get 96x, new power is 7, plus 3 falls down, 18x squared. And if I go all the way back to that first problem I had, that was the exact answer we got using the product rule. So even this second problem, I could FOIL that out. I could do all my distribution and then totally avoid the product rule. I could do the same here, do all the multiplication, totally avoid the product rule. But the product rule, so I guess the point I'm trying to make is the product rule is like not always needed. But in a problem like this, it is. Because I have x squared minus 1 times cosine of x. And I can't just distribute that. I would actually still need the product rule. So this is a great example of a problem where you like literally have to use the product rule. So there's my u and there's my v. So to find the derivative of f, I'm going to start off with u, x squared minus 1. And I'm going to multiply by the derivative of v, which is cosine. The derivative of cosine is negative sine of x. Please use parentheses. Just as a quick side note, I get a lot of kids that won't use parentheses there, and they'll write x squared minus 1 minus sine of x. They won't use parentheses, so it actually looks like x squared minus 1 minus sine of x, but it's not. It's x squared minus 1 times negative sine x. So be careful using parentheses. Plus, then we're going to leave v alone. That's cosine of x, multiplied by the derivative of u, which is 2x minus 0, so just 2x. And voila, I'm actually done. There's not a whole lot of cleanup I could do. I could distribute that, but actually, I would actually just rather leave the problem like this. You know, a couple little things I could do here. I could put the 2x in front. Order of multiplication does not matter. So that'd be 2x times cosine of x. Then I actually don't need the parentheses if I'm careful with that. Over here, I could take the negative and distribute the negative to get 1 minus x squared. Hopefully you see what I did there. The x squared became negative. The 1 became positive. So I switched the order there. That way it looks a little bit nicer. Times sine of x. That would be a little bit better. I could distribute that sine of x and get sine of x times 1, which is sine of x, minus sine of x times x squared, plus the 2x times cosine of x. That all looks a little bit better. Some people might even move that x squared right here to the front. That way you don't think it's inside the sign. So we'd have sine of x minus x squared times sine of x plus 2x cosine of x. You know, so a couple different things I could do algebraically here to clean this one up. But at the end of the day, I really do need the product rule here to answer this question. So it's a pretty good one. Hopefully no major issues there. Hopefully that all makes sense. But like I said multiple times in this video, and I really mean it, please be super careful because a lot of students, the issues come after they use the product rule. So my recommendation is use the product rule. Don't try to do too much at once, and then carefully do algebra to clean it up if necessary. All right, that's it for the product rule. Hopefully you love it.